In this video, we're going to take a look at solving rational equations. So let's take a look at a basic example first. So we have 2/5 is equal to 4 over x. So in this basic example, we can cross multiply to solve for x. So I would say 2 times x is equal to 4 times 5. So that would give me 2x equals 20, and I could divide by 2, and I get x equals 10. And so that would be my solution for this simple equation that's rational. And then I would just need to note that x cannot equal 0 because it is in the denominator right there, and our denominator can still never equal 0. So with solving rational equations, there are two types. Sometimes you have a basic one like the one we just saw, where you have one rational expression equals one rational expression. And to solve it, you can just cross multiply and check for extraneous solutions. And the second type is if you have more than two rational expressions in the equation. And to solve those, you just need to find the least common denominator and then cancel out all the denominators once they are the same and solve the remaining equation. So we're going to look at some examples of both. Now, an extraneous solution is a solution that is a restricted value. So it's when you come up with a solution, but it is restricted. So we've talked a lot about restricted values. We'll just check for those in each of our examples and reiterate that. So let's look at example 1. It says solve for x, check for extraneous solutions. So we have one fraction is equal to one fraction. We can cross multiply and write that out. So 3 times x plus 2 is equal to 5 times 4x. All right, so then let's distribute the 3, and we get 3x plus 6. And then 5 times 4 is 20. Let me move that. So 20x. All right, so let's subtract 3x, and we get 6 equals 17x. And then just divide by 17. So we end up with 6 over 17 is our solution. So check the same way we did before with our simplify, multiply, divide, all of those sets of notes. X cannot equal 0 on the left, and x cannot equal -2 on the right. So since our solution is not one of those values, it is not extraneous. So we have checked for that. And that's all you need to do for that. So number 2, we have x squared minus 3 equal over x plus 2 is equal to x minus 3 over 2. So it's still one fraction is equal to one fraction. So let's go ahead and cross multiply. And let's say 2 times x squared minus 3, the ones that are diagonal from each other, get multiplied. And then x plus 2 times x minus 3. So on the left, I'm just going to distribute the 2. So I get 2x squared minus 6. And on the right, I need to FOIL it. So if we FOIL this, we would get x squared minus x minus 6. And you could certainly work that out on the side with the box or the FOIL method, and you should get what I got. But to save time, I'm just going to keep going. So we got to subtract x squared. So 2x squared minus x squared would just give us x squared minus 6, and then negative x minus 6. And so what this gives us is a, let's see, quadratic equation, because we have something squared. So I see I have minus 6 on each side. If I add 6, those cancel out. And so then I end up with x squared equals negative x. So what I want to do is move everything to one side. Let me move over here where I got a little more room to write. So x squared currently is equal to negative x. Let's add x. So I get x squared plus x equals 0. And then I'm going to solve by factoring. So I'm going to factor out x. And I get x plus 1 left over. So x times x plus 1 equals 0. So what that means is x equals 0. Remember, you can set your factors equal to 0 to finish solving. So x equals 0 and x plus 1 equals 0. Subtract 1 and you get x equals -1. And then I'm going to magically move this up and try to shrink it a little. Wait a minute. Let me try that again. Just so it'll fit in that space a little better. Okay, there we go. So we have solutions x equals 0 and x equals -1. We just need to check and see if those are extraneous. So when you look at your denominator in the original problem, you would say x cannot equal -2. But since it's not that, then you have no extraneous solutions. So we're good. All right, so let's take a look at number 3. For number 3, it's another example of when you have one fraction is equal to one fraction, so you can cross multiply. So let's say x times x minus 2 equals 3 times x plus 2. So I'm going to distribute the x and I'm going to distribute the 3 for the next step. So I get x squared minus 2x equals 3x plus 6. Then it's a quadratic equation again, so let's move everything to one side. So I'm going to start by subtracting 3x. So I get x squared, -2 minus 3 would be -5x equals 6. And then let's subtract the 6 from both sides, so you get everything on one side, and we can solve it using any of those ways you can solve quadratics. So you could do quadratic formula, you could try to factor it, graph it. There's a couple things we could do. Usually the quickest way, since we've been talking about factoring a lot, is just to look at it as factoring. So what could I multiply to get -6 and add up to get -5? So I could say that would be -6 and 1. And if I set each of those equal to 0, I can quickly finish solving for x. So I would get x minus 6 equals 0. So x equals 6 for one of my solutions. And x plus 1 equals 0. So x equals -1 as another solution. So we'll circle those and then check for extraneous solutions. Those are just checking that your restrictions don't interfere with your solution. So x cannot equal 0 on the right, and x cannot equal -2 on the left. But neither of those was a solution I came up with. So I have checked my answer. All right, let's look at number 4. Now 4, 5, and 6 are type 2 rational equations. They have more than one fraction on each side. They have like more going on. 1, 2, and 3, those were all type 1. So what I'm going to write out here is that these are all type 1, like 1, 2, and 3. Let's circle 1, 2, and 3. But then number 4, 5, and 6 are all going to be type 2. All right, so that way we can look at 3 of each. So let's start with number 4. We've got 3 halves plus 1 over x equals 2. So the first thing I want to do in this case is find a least common denominator. So treat that 2 on the right like there's a 1 at the bottom. And then I'm going to make them all become the same. So to make them all the same, I just need to have 2 and x. Because I can now multiply the first fraction by x, the second fraction by 2, and the third one by 2x. And that way they will all become the same denominator. So I get 3x over 2x, 2 over 2x, and 4x over 2x. Now what's really nice is after you do that, you can cancel all of the denominators now that they are the same, and you can just solve what's left in your numerator. So in my numerator, I have 3x plus 2 equals 4x. So let's just subtract 3x from both sides, and we get 2 equals x. All right, so if we check for that extraneous solution again, the only part that would make something extraneous is this little x in my denominator in the original problem. And we just need to know that x cannot equal 0, but since I didn't get 0 for my solution, I'm good. 2 is okay. Let's look at number 5. So number 5 has 8 over x plus 2 plus 8 over 2 equals 5, and put a 1 at the bottom whenever you have a plain constant like that. Treat it like a fraction. So we can make each of these denominators be the same if we make them all 2 times x plus 2. Okay, so to do that, I can multiply the first one by 2. I can multiply the second one by x plus 2, and I can multiply the third one by 2 and x plus 2. And then just do the same thing in the numerator that you do in the denominator. So 2 times 8 would be 16. 8 times x plus 2 would be 8x plus 16. And then we have 5 times 2, which is 10. And then 10 times x plus 2 would be 10x plus 20. Now, after all that hard work of getting your denominators the same, you're able to cancel them out and just bring down what's left in your numerator. So I'm just going to write it first, and then we'll work on cleaning everything up and solving. So I have 16 plus 8x plus 16. So that would be 8x plus 32, because 16 and 16 are constants. We can add those together. And then we have 10x plus 20 on the right. So I'm going to subtract 8x from both sides, and I get 32 equals 2x plus 20. Let's subtract 20. So we get 12 equals 2x, and then just divide by 2. So I solve, and I get x equals 6. Let's check and make sure that would not be extraneous. So in my original problem, I have x plus 2 as a denominator. So x cannot equal negative 2. But that would be the only restricted value, and we didn't get that for our solution, so we're good. We don't have any extraneous solutions. Okay, so for our last example, let's look at number 6. We have 5x over x minus 2 equals 7 over 1, and then 10 over x minus 2. So what we can do now is let's just do this the same way we did the others. So I'm going to make them all have a common denominator of x minus 2. So 5x already has that denominator, and 10 already has that denominator. So the only one that needs extra work is the 7. So I need to multiply the 7 by x plus 2. And I'm just going to write that down. Or excuse me, x minus 2. All right. Let me fix that one. So x minus 2. And then once we get the denominators to match, we can cancel them out and bring down the numerator. So you get 5x equals, I'm going to go ahead and distribute the 7. So I get 7x minus 14 plus 10. And then from there, it's just a linear equation. So let's say 5x equals 7x, and then negative 14 plus 10 is negative 4. And then I'm going to subtract 7x because I don't want to end up with nothing on the left. So in that case, I'm going to get negative 2x equals negative 4, and then finish up by dividing by negative 2. So I get x equals 2. And then to check and make sure it's not extraneous, we have to look at our original problem. So in our original problem, we have two denominators of x minus 2, so x cannot equal 2. And so what happens is this is an extraneous solution. And if x equals 2 was the only solution we have, then we have to say that this equation has no solution because x equals 2 is an extraneous solution. All right, so that's it for solving rational equations.